Welcome to KISS Math. Here are some more example problems on finding the least common denominator. So here's our first example. Our denominators here are 27 and 9. So what I'm going to do is start listing out the multiples of both of these and seeing if I can find a common one. So for 27, the first one, and then we have 54. That's about as much as I can do. For 9, we have 9, then we have 18, 27, 36, and here we go. We already got our first common multiple of 27. So 13 over 27, well, we don't have to do anything on this one. And then for 7 over 9, we know it's something over 27, and we had to multiply by 3 to get to 27, so we do the same for the top, and that gives us 21 over 27. So to answer the question, the least common denominator is 27. That's our final answer. And then the extra work we did with the fractions, that's just kind of icing on the cake there. So listing out the multiples like this is a pretty foolproof method of finding the LCM. But right off the bat, I can check to see if one of these denominators will divide evenly into the other. And if it does, then the larger one becomes the least common multiple, or the least common denominator. So in this case, if I wanted to take a shortcut, I could say, yes, 9 goes into 27 3 times. It is a multiple of the other denominator. So 27 would be our least common denominator just by looking at these two. Okay, here's another one. Our denominators here are 18 and 24. And we check, does one denominator divide evenly into the other? No, 18 would not go into 24 evenly. So we'll start listing the multiples. So we have 18, 36, and 54, and 72. And you can punch these in the calculator to verify that. 24, 48, and 72 are the multiples of 24. And we found our first common multiple. So this becomes our least common denominator. So that is the actual final answer, but if we want to take it a step further, we have 5 over 18 will become something over 72, and we have to multiply by 4 to get to 72. So I do the same thing up top, and I get 20 over 72. And then for 7 over 24, it'll be something over 72. And I know I have to multiply by 3 to get to 72. So I do the same at the top, and I get 21 over 72. So this is kind of the opposite of reducing fractions. And the reason we do that is that we want them to have the same denominator so that, like I said before, we're kind of, it's like they're sharing frequency. They can talk to each other, so we can add and subtract these later down the road. Okay, 25 and 9. So I'll do the same thing, listing out the multiples. 25, 50, 75, 100. And then for 9, 9, 18, 27, 36, 45, 54, 63. So I'm not seeing any common multiples here, and I might be going on for a while. So why don't we try the ladder method here? So we have 25 and 9, and we think of a number that would divide evenly into both of these numbers. You could try maybe 3. 3 would go into 9 3 times, but 25 is not divisible by 3. You could say maybe 5, but 9's not divisible by 5. And you would go through all the numbers and realize there's not a number that would go into both of these evenly except 1. So 1 would go into 25 times, same thing with 9. And since you're left with the same numbers, there's nowhere else to go. You're done. So your L would look like that. And you would just multiply 1 times 25 times 9, which happens to be 225. And so when you have two fractions like this, as a last resort, you can multiply the denominators together to get a common denominator. But that doesn't guarantee that it's the least common denominator. The only way to guarantee that it's the least common denominator is to do this ladder method here, or continue listing out all of the multiples here. So if we kept listing out the multiples for 9 and 25, we would eventually get to 225, and that would be the least common denominator. All right, how about if we have more than two fractions? So here we have 3 denominators, and we want to find the LCM between them. Well, it's no different than just finding the LCM between 2. We just follow the same steps. So for 5, we list out the multiples: 5, 10, 15, 20. And for 4, we have 4, 8, 12, 16. And for 8, which is our third denominator, we have 8, 16, 24, 32, 40. I'm still not seeing a common denominator, so I'm going to keep going. So for 5, I'll have 25, 30, 35, 40. Okay, maybe 40 will be our denominator. Let's try continuing with 4. 20, 24, 28, 32, 36, 40. So yes, 40 is the first multiple which is common to all 3 of these denominators. So that's our answer. But let's take it a step further. So 1/5, it would be the same thing as something over 40, and we'd have to multiply by 8 to get to 40. So we do the same thing on top and get 8 out of 40. For 3 over 4, we need to multiply by 10 to get to 40 on the bottom. So we do the same thing on the top, which would be 30. And then for 5/8, we need to multiply by 5 to get to 40. Same thing on the top. 5 times 5 is 25. So let's see if we can get the same answer using the ladder method. So we have our 3 denominators, 5, 4, and 8. And if you remember, we're trying to find a number that will go into all 3 of these denominators evenly. But if you can't, the next step is to find a number that would go into some of these denominators evenly. So there's not a number that goes into all 3, but I see a 4 and an 8, and I know both are divisible by 4. And so 4 will go into 4 one time, and 4 will go into 8 2 times. But 4 will not go into 5 any time, so I just bring that down here, and then I try again. At this point, there's not a number that would go into all 3 numbers or even 2 of these numbers. So at this point, I'm done. I draw my L, and I will multiply all of the outer numbers. So I'll get 4 times 5, which is 20, times 1 is 20, times 2 equals 40, which is the answer we got using the brute force method of listing out all the factors. All right, how about 4 denominators? The problem with having so many denominators is that it'll be harder to find a match between all of them. But let's try and list out the factors and just see what happens. So we have 12, 24, 36, 5, 10, 15, 20, and then 16, 32, 48. No real obvious matches so far. And then 21, 4263. So I can see that this 21 is going to be giving me problems because the numbers will get so large that I'll have to list out a bunch of factors on the other denominators to try and find a match for it. So in this case, the best way is to use the ladder method with 4 denominators. So we'll list them all out here. And we'll first try and find a number that will go into all 4 of these. And I'm not seeing any. So then I'll see if I can find a number that goes into some of them. So I see that maybe 3 would go into 12 4 times. And it would go into 21 7 times. But it would not go into 5 or 16, so I have to bring those down. And then try again. Now, there's not a number that goes into all 4 of these, or even 3 of them, but there is a number that goes into 2 of them, which is 4 and 16. So 4 would go into 4 1 time, and it would go into 16 4 times. It would not go into 5 evenly, so I bring that down, nor 7, so I bring that one down. And then at this point, I'm done because I can't find a number that would go into 2, 3, or 4 of these numbers at once. So I draw my L. And I'm going to multiply all these numbers. So 3 times 4 times 1 times 5 times 4 times 7. And if I punch that into the calculator, I would get 1680. And that would be our least common denominator. Now, if I try and get the same answer by listing out all the factors, it would take me a very long time. So that's kind of the advantage of using the ladder method here.